Hi everybody, in this video we're going to go over the review sheet for test number 2. So in this first question, it's asking us what is the distance from campsite A to campsite B. So we're finding this distance to the nearest yard, which is the nearest whole number. Now we have a right triangle here, and we know two sides already of the right triangle. So what I'm going to do here is use the Pythagorean theorem in order to find the missing side. Remember, for the Pythagorean theorem, the hypotenuse, which is across from the 90-degree angle, needs to be plugged in for C. It doesn't matter which leg you put as A and which leg you put as B, but it does matter that C is the hypotenuse. So let me use my calculator now. 1,300 squared. Okay, this is 1690000. Okay, 1,700 squared. That is 289, and then 4 zeros after that. Let me subtract, and I get that b squared is equal to 1, 2, 3, that's 5 zeros. And we need to take the square root of both sides. So b is approximately, it does say to the nearest yard, 1,095 yards, because I got 1,095.4. So that keeps it the same, because we're not rounding up. We only round up when it's 5 or above. So 1,095.4, keep it as 1,095. That's rounded to the nearest yard. Okay. JT is 12. That's the hypotenuse of this triangle. JM is 6. And here we have the 90-degree angle. And it's asking what is the value of cotangent of angle J. Cotangent is the reciprocal of tangent. And tangent is opposite over adjacent. So that means cotangent is going to be the reciprocal, which is adjacent over opposite. We just flip the fraction. So from angle J, which is my focus angle, I'm going to need adjacent and opposite. I don't have opposite, so I can find it because I do know two sides of this right triangle, so I can find the missing one, once again with Pythagorean theorem. So we have 6 squared plus b squared is equal to 12 squared. 36 plus b squared is equal to 144. Using my calculator, 144 minus 36 is 108. So we have b is equal to radical 108. And I'm just going to simplify that radical on my calculator. So in my y equals, I'm going to type in 108 divided by x squared. I'm going to hit second graph and get my table of values. And I'm just looking for the last place where I see whole numbers in that table of values. And it's looking like 6 radical 3. Yes, 6 radical 3 is going to be simplest form. So b is equal to 6 radical 3. So let me put that here, 6 radical 3. That's the simplest form of radical 108. Okay, from here, let me write my cotangent ratio. So cotangent is adjacent over opposite because it's the reciprocal of tangent. So here we have adjacent to angle J, and here we have opposite. So adjacent over opposite. But remember, we can't leave a radical in the denominator, so we have to rationalize it by multiplying the top and the bottom by the radical we want to get rid of from the denominator. So in the top, we have 6 radical 3 over radical 3 times radical 3 is just 3. So we have 6 times 3, which is 18. 6 and 18 divide evenly. So we have, let me just put an arrow down here, radical 3 over 3. Because 6 and 18 both divide by 6. 6 divided by 6 is just 1. So 1 radical 3, or radical 3 for short. And 18 divided by 6 is 3 for the denominator. Yeah. Okay. We know that the two triangles are similar. So remember, similar triangles have proportional corresponding sides. Let's take a look. Cosine is adjacent over hypotenuse, right? If you don't remember, just write down SOHCAHTOA, adjacent over hypotenuse. So from angle J, adjacent would be JM, and hypotenuse would be JT. This doesn't say JM over JT. But remember, in similar triangles, the corresponding angles are congruent. So this angle and this angle correspond, so they're congruent. And the corresponding sides are proportional. So cosine of angle J is the same thing as cosine of angle E, because we have similar triangles. So from angle E, adjacent would be ME, and hypotenuse would be RE. That's still not what it says here. I don't see ME over RE. So this choice is not correct. Let's reset and let's take a look at the other choices and see which ones are true. Once again, we're talking about cosine, but this time of angle R. So cosine of angle R is going to be the same thing as cosine of angle T, because they're corresponding angles of similar triangles, and the sides are proportional in similar triangles. So from angle T, here's adjacent, and here's hypotenuse. And from angle R, here's adjacent, and here's hypotenuse. So let's see if it says TM over JT or RM over RE. No, neither one of these are correct. So that's not the choice we're looking for. Let's move on to the next one. Tangent. Tangent is opposite over adjacent. So tangent of angle T would be JM, that's opposite, over adjacent, over TM. It doesn't say that. It doesn't say JM over TM. But remember, tangent of angle T is the same thing as tangent of angle R, and opposite would be ME, adjacent would be RM. Doesn't say that either. It's reversed. It doesn't say ME over RM. That's not the choice we're looking for. So that tells me the last one's probably going to be true. But let's see why. Otherwise, we did something wrong. We have to go back. Once again, tangent. From angle E, tangent would be RM over ME. It doesn't say that here. But remember, tangent of angle E is the same thing as tangent of angle J. Opposite would be TM over adjacent JM. And that's exactly what this one says, TM over JM. We found the correct answer choice. It was really annoying to go through all of them, but we found it. Okay, let's take a look over here. Which proportion would always represent a correct relationship of the segments? So we have to think about the leg rule, the altitude rule, because I see a big right triangle with an altitude drawn to the hypotenuse. So that tells me leg rule or altitude rule, right triangle altitude theorem whenever you see this diagram. So let's check it out. C, that's the whole hypotenuse. So this would have to be the leg rule, because the leg rule is the one that uses the whole hypotenuse. And the leg rule says that the leg of the right triangle is the mean proportional between the whole hypotenuse and the part of the hypotenuse directly below the leg. But I see that there is z in here, and z is the altitude. So this is not correctly set up for the leg rule. Okay, number 2. C. So once again, C is the whole hypotenuse. So this would have to be the leg rule. The altitude rule doesn't use the whole hypotenuse in it. So let's see if these are a leg and if this is the part of the leg, part of the hypotenuse directly below that leg. A is a leg, so that's good so far. But then it would need to be using a part of the hypotenuse directly below that leg, which is X. But that's not what it says here. It says Y. So nope, not correct. Moving on. X. So that is the part of the hypotenuse below this leg. So it could be leg rule. It also could be altitude rule because altitude rule uses both parts of the hypotenuse. I see that there's no A mentioned here, so it's not going to be the leg rule. If it is, it might be altitude rule, so let's check that out. Altitude rule says that the altitude is the mean proportional between each part of the hypotenuse. So this is a part of the hypotenuse, and the other part is here. And let's just check that z is the altitude. It is. That is correct. 3 is the correct one here. It's the only one that's correctly set up, either the leg or the altitude rule. Let's draw a picture over here. So we have a right triangle, and C is the 90-degree angle. So I'll just make this A and B. And lowercase a, opposite from angle A, is 4. And sine of angle A is 1/2. Sine is opposite over hypotenuse. So from angle A, opposite over hypotenuse is 1/2. But opposite from angle A, we have here is 4. So what could we put as the hypotenuse to make 1/2? Try out each of the answer choices. If you put 8 here, 4 over 8 is 1/2. So that's the one that we're looking for. If this is 8, opposite over hypotenuse would be 4 over 8, which is 1/2. Moving on, we're looking for when sine and cosine are equal. Sine and cosine are cofunctions, so they're equal when their angles add up to 90 degrees. So here's the sine angle and here's the cosine angle. So let's add them and make them equal to 90 degrees. And that sine and cosine are going to be equal to each other when their angles add up to 90 degrees. So we have 6x equals to 90. And let me divide by 6 on both sides. 90 divided by 6. And I have x is equal to 15. So our answer, because we're just finding x, is 215. If you wanted to verify that you were correct, you can take your x value and plug back in. 15 times 2 is 30, plus 7 is 37. 15 times 4 is 60, minus 7 is 53. And in your calculator, if you hit sine 37, I get like 0.6018. And if I hit cosine of 53, I get the same thing. I can check in my calculator to make sure that the x value that I found for the angles really does make sine and cosine equal to each other. Okay, moving on. The perimeter of an equilateral triangle is 18. That means each of the sides is 6 to make that 18. What is the length of the altitude? Equilateral triangles have 60-degree angles. And that makes this piece 30 and this piece 30 because all 3 angles of any triangle need to add to 180. So we have 30, 60, 90 triangles here. And let me fix that because that's a little confusing. The whole side is 6. So here we have 3 and 3 for that. So the short side is 3. Remember, 30, 60, 90 triangles are in the ratio 1 to radical 3 to 2. The altitude is across from the middle biggest angle. So that's the radical 3 part of the ratio. Let's get from the shortest side to the middle biggest side. We just multiply by radical 3. 3 times radical 3 is 3 radical 3. And that's all it is. In triangle ABC, angle C is 30 degrees and lowercase a is 8. If the area of the triangle is 12, what is the length of lowercase b? So it is talking about the area of a triangle, and I don't see a height here or a base. So I'm going to use my new area of a triangle formula with trig. And that was area is 1/2 AB sine of angle C. Now we know the area, we know it's 12. And one of our sides is 8. We don't know what the other side is, so I'll just leave it as B. Sine of the angle in between, which is 30. Okay, using my calculator, I have 12 is equal to 1/2 times 8 is 4. Let me divide by 4 on both sides. And the very last thing that I need to do to get b by itself is divide both sides by sine of 30. So on my calculator, let me do 3 divided by sine of 30, and I got 6. It worked out nicely. So side B is 6. Okay. The sides of a parallelogram are 310 feet and 840 feet. So let me draw my parallelogram. 310 feet and 840 feet. And the included angle, that means the angle in between the sides, is 63 degrees. What is the area of the parallelogram? Well, if we draw in a diagonal, we now have 2 triangles. And we know how to find the area of any triangle when we have 2 sides next to each other and the angle in between. We have our new formula, 1/2 AB sine of C. So one of our sides is 310. Our other side is 840. Sine of the angle in between the sides, which is 63. Let me go into my calculator. I'm going to type this in. 1/2 times 310 times 840 times sine of 63 degrees. I hit enter and I got approximately 116,009.049. There's more decimal places. But recognize that this is the area of just one triangle. There are 2 triangles making up this parallelogram. So I have to multiply in my calculator what I got by 2. And to the nearest foot, when I multiply by 2, I get approximately 232,018 feet. Okay. A diagonal of a square measures 18 centimeters. And this is a square, so there's 90-degree angles. And that makes this 45 and 45. 45 and 45, because this is a square. We have 45, 45, 90 triangles. And what we need to do is find the side length so we can find the perimeter. Now remember, in a 45, 45, 90 triangle, the ratio is 1 to 1 radical 2. And we know the biggest side. We know the hypotenuse. So we need to get back to the smaller side. So we need to divide by radical 2. So 18 divided by radical 2. We can't leave a radical in the denominator, so we're going to rationalize it by multiplying top and bottom by radical 2. So we have 18 radical 2 over 2. 18 and 2 divide evenly, so that's 9 radical 2. So 9 radical 2, 9 radical 2, 9 radical 2, 9 radical 2. So that would be 36 radical 2 for the entire perimeter. Okay, let's take a look over here. We need to find the distance between the park ranger station and the lifeguard chair. So first we're finding this. And the easiest approach is that we have a right triangle over here. That's 90, so this has to be 90 because they're supplementary. So we have two sides of a right triangle, so why not use the Pythagorean theorem to find the missing side? So I'll put this right here for A, and we do know the hypotenuse, so that needs to go in for C. So A squared plus 0.25 squared is equal to 0.55 squared. So on my calculator, 0.25 squared is 0.05, and on my calculator, 0.55 squared, oops, I just typed that in wrong, is 0.3025. So let me subtract that by 0.0625, and I got A squared is equal to 0.24. So our last step to get A is to just square root both sides. And it does say to round to the nearest hundredth of a mile. That's 2 decimal places. So on my calculator, I'm going to square root 0.24. And to 2 decimal places, I got A is approximately 0.49. It rounds up. So this is approximately 0.49 miles. Gerald believes the distance from the first aid station to the campground, so from here to here, is at least 1.5 miles. Is Gerald correct? Well, look at what I see here. I see a big right triangle with an altitude drawn to the hypotenuse. And I want to find the whole hypotenuse. So I'm going to think right triangle altitude theorem. I'm going to think either leg rule or altitude rule. Now I'm going with leg rule because leg rule uses the whole hypotenuse. We have a leg, we have part of the leg, part of the hypotenuse directly below that leg. So remember, the leg rule says that any leg of the big right triangle is the mean proportional between the whole hypotenuse. That's what we're looking for. So I'll call that X. And the part of the hypotenuse directly below that leg, which here would be 0.25. From here, I'm just going to cross multiply. 0.25x is equal to, let me multiply the other way, 0.55 times 0.55, and that's 0.3025. Dividing that by 0.25 to get x by itself, I get x is equal to 1.21. Is that at least 1.5 miles? No. Gerald is incorrect. It doesn't say to explain your answer. It just says to justify it. That means to just show work. But you do have to answer the question to get full credit on something like this on a test or the Regents exam. If you don't say whether Gerald is correct or incorrect, you don't get full credit for the question. So it's enough to just show work to justify it, but you do need to actually answer the question. No, Gerald is incorrect. If I wanted to explain it, which I don't have to, but if I wanted to, I could say the actual distance is only 1.21 miles. That is not 1.5 miles or greater than 1.5 miles. That is less than 1.5 miles. Okay. At Mogul's Ski Resort, the beginner's slope is inclined at an angle of 12.3. So here's our ski slope. While the advanced slope is inclined at an angle of 26.4. Okay, so this will be my beginner's slope. So I'm going to call that beginner's slope. And I need a different ski slope for the advanced slope. So the beginner's slope is inclined at an angle of 12.3 degrees. Sorry, that's really hard to see. I shouldn't be using all this blue over there. 12.3 degrees. While the advanced slope is inclined at an angle of 26.4 degrees. If Rudy skis 1,000 meters down the advanced slope, while Valerie skis the same distance on the beginner slope, how much longer was the horizontal distance that Valerie covered? Oops, my bad. I put the angles in the wrong spot. Let's fix that. You probably realized that as well. My bad. Let's fix it. So the angle that it's inclined at is the angle of elevation of the ski slope. So that would be here for the beginner slope, inside the triangle next to the right angle. And that would be here for the advanced slope, inside the triangle next to the right angle. And it's also the angle at which the slope is inclined at, because it's the angle that it's sloping. And that's the angle of elevation. Okay, so here we have it labeled correctly. So from our focus angle, we are looking for adjacent, and we have hypotenuse. Same thing here from our focus angle, we are looking for adjacent, and we have hypotenuse. So let's set up some cosine ratios, because cosine uses adjacent and hypotenuse. So cosine of 12.3 is equal to adjacent over hypotenuse. Putting this over 1 and cross multiply. So x is equal to 1,000 times cosine of 12.3. So that's about 977 meters. Now let's set up over here. Cosine of 26.4 is equal to x over 1,000. X is equal to 1,000 times cosine of 26.4. So that's about 896 meters. So Valerie was on the beginner slope and Rudy was on the advanced slope. So we see that Valerie did cover more distance. The question is how much more distance? So now that we found the two distances, we just need to subtract them. So in the calculator, I'm going to subtract my 977 number minus the 895 number, and it's about 81.3 meters more, because it didn't ask for how much it was, it asked for how much more it was, how much longer it was. There we go. Okay, let's see what this one is asking. At what angle would the highway need to be built? So that's the first part of the question. So this is the angle that we're finding. From this angle, we have opposite and we have adjacent. So that's tangent, O over A. So tangent of angle X is equal to opposite over adjacent. Now remember, to get the X from being trapped inside tangent, we have to cancel tangent out anytime we're solving for an angle. So that is inverse tangent. Let me put this into my calculator, and it does say to the nearest degree. So that's to the nearest whole number, 280 over 170. And I got approximately 59 degrees to the nearest whole number. So that's part A. So this is 59 degrees. To the nearest mile, how many miles would be saved by traveling directly from New York City to Buffalo rather than by traveling first to Albany and then to Buffalo? So we need to find this length over here. I used X before, so I'll call it Y. So our focus angle is our 59-degree angle, and this time we need to find the hypotenuse. So you can either use sine, which is opposite over hypotenuse, or you could use cosine, which is adjacent over hypotenuse. Both would work here. I guess I'll use cosine because 170 is smaller than 280. I don't know. It doesn't really matter. So let me put that over here. Cosine of our 59-degree angle that we found is equal to adjacent, which is 170, over the hypotenuse, which I called y, which is what we're finding. Let's cross multiply and solve. So we have y cosine 59 equal to 170. Now I just need to divide both sides by cosine of 59. So in my calculator, I'm going to do 170 divided by cosine of 59. And it does say to the nearest mile, how many miles would be saved. So this is approximately 330.1. I'll round as my very last step according to the question. So this side over here is 330.1. If this person was to go directly from New York City to Albany and then to Buffalo, they would be traveling 170 miles and then another 280 miles. So they'd be traveling 450 miles to go from New York to Albany to Buffalo. So I'll write that here. 170 plus 280 is equal to 450. So it says how many miles would be saved traveling directly, only going 330 miles. 450 minus 330.1, or just 330. It doesn't really make a difference. Is 119.9, which is approximately to the nearest mile 120 miles that are saved by going this way rather than this way and that way. Moving along. And I'm trying to go through these a bit slow as well. Okay, so we need to find angle theta. And there will be a question just like this on the test. This comes up like on every single Regents exam with these angles, like the exact same question, literally, not even kidding. So remember that we can only use trig ratios with right triangles. So we actually do have two right triangles over here. We have the smaller right triangle here. I'm going to erase that. I just wanted to show it to you guys. And then we have the whole big right triangle. So just recognize that we have two right triangles here. This one over here that doesn't have theta, and the whole one. The triangle that has theta in it, this triangle over here, doesn't have a right angle. So we can't use a trig ratio with it. So my plan is going to be to find the whole angle of the big right triangle, to find this part of the angle from the small right triangle, and to subtract the two to be left over with the angle that we're actually looking for. So I'm going to write here big triangle, and we want to find this angle. So that's our focus angle, this whole angle. From this angle, we have this side and we have this side. That side is 1.17. Let me get my calculator back out. Plus 0.41. So that is 1.58. So we have opposite and we have adjacent. So that is tangent, opposite over adjacent. So from the big triangle, let me set up my tangent ratio. Tangent of the angle that we're looking for, I'll call, not the angle we're looking for, the whole big angle here, I'll call that x, is equal to opposite, which is 1.58, over adjacent, which is 3.74. Now remember, when I'm solving for an angle, I just need to use inverse trig to cancel out the trig function and get the angle out from inside. So inverse tangent of 1.58 over 3.74 will give us the whole big angle from the big right triangle. So in my calculator, second tangent, let me get my fraction button, 1.58 divided by 3.74. Okay, so x is approximately 22.902. I want to keep a couple of decimal places to the end. If you round early, it actually might impact your answer at the end. So that's the whole big angle. Now, from the small right triangle, we're going to find that angle, the one that I marked in blue. And then once we have the whole big angle and this piece, we could subtract and get the one that we actually want, theta, the projection angle. So let's do it. From this blue angle, which is going to be our focus angle because we're looking for it, and we can call it y. So from angle y, we know opposite, it's 0.41. And once again, we know adjacent, it's 3.74. So since once again we have opposite and adjacent, that's going to be tangent. So tangent, and I just called that angle y just so it has a different name than this one and we don't get confused, is equal to opposite is 0.41. That's just from that triangle. And adjacent is 3.74. Same thing. Inverse trig. Let me go into my calculator. Second tangent 0.41 over 3.74. And it's approximately 6.256. So now I just need to subtract the smaller angle from the bigger angle. So 22.902 minus 6.256. And I do need to round to the nearest tenth of a degree. I just subtracted in my calculator, and tenth is one decimal place. I got approximately 16.6 degrees. Oops. 16.6 degrees. There we go. Okay. This one uses the law of sines, which actually will be on your test, but nothing like as complicated as this. So most of the stuff is labeled here. BE is congruent to ED. So if BE is 6, ED is also 6. And GF is congruent to FB. So I'm going to mark that as well. First, we need to find angle A. The first thing I'm going to do is I see I have a right triangle over here. And in this right triangle here, I do know two sides, the 6 and the 10. So I can use the Pythagorean theorem to find the missing side, FB. So 10 is the hypotenuse. So I'm going to do 6 squared plus b squared is equal to 10 squared. That's 36 plus b squared is equal to 100. Let me do 100 minus 36. That's 64. So B is equal to 8. So this is 8, and then since these were congruent, this is 8 as well. So that means that this whole side here, GB, is 16. Now, notice that the triangle that we want to find angle A in is not a right triangle. So trig ratios are not going to work to find that angle. We're going to have to use law of sines. So let me set that up. Now, we want to find angle A, so that's got to be there. And the side across from angle A we just found to be 16. The only other angle in this triangle we have is the 40-degree angle, and we do have the side across from it, that is 15. So if we cross multiply, we have 15 sine of angle A is equal to 16 sine of 40 degrees. If we divide both sides by 15, it cancels out from here. And we have sine of angle A is equal to 16 sine 40 over 15. Remember, to undo the sine function, we take inverse sine. So inverse sine of 16 sine of 40 over 15 will give us the angle. And it does say to the nearest tenth. Let me get my calculator out. Second sine. Let me get my fraction button. 16 sine of 40 degrees over 15. Enter. That is approximately 43.3 degrees. So A is approximately 43.3 degrees to the nearest tenth. Now it says to find BC to the nearest tenth. So BC is part of this triangle down here, which is not the right triangle. So trig ratios are not going to work. Our only option is law of sines. Since each part of this side is 6 and 6, the whole thing, BD, would be 12. Keep in mind also that together, all three angles here make a straight line, 180 degrees. This one's 40 and this one's 90. So we can find this angle because it needs to make 180 degrees with the other two. So I'm going to do 40 plus 90, and that is 130. 180 minus 130 is 50. So this angle right here actually is a 50-degree angle. And the problem here is that to find BC, using the law of sines, BC is right over here, I would need the angle across from it, angle D, which I don't have. So I'm not going to be able to find angle D right away. I do have this side 12, which is across from angle C. So if I find angle C first, then I can find angle D and use it to find BC. So that's why this is a challenge question, because this is like multiple parts over here. So let's do it. I'm going to use the law of sines to find angle C. So sine of angle C, 12 is the side opposite from that. The only other angle we have is the 50-degree angle, and the side across from that is 10. So when we cross multiply, that's 10. Sine of angle C is equal to 12 sine of 50 degrees. If we divide by 10 on both sides, we have sine of angle C is equal to 12 sine of 50 over 10. Let's inverse sine this in order to get angle C. So angle C is approximately, let me put this into my calculator, second sine for inverse sine, 12 sine 50 over 10. And I got approximately 66.8 degrees. So this is approximately 66.8 degrees. If I add 50 to that, I get about 117 degrees. And if I subtract that from 180, and I'm going to leave to the nearest tenth, I get approximately 63.2 degrees for angle D. And now that I know angle D, I can use law of sines to find BC, which I'll label as X, because that's what we're actually looking for here. So sine of 63.2 over X is equal to, and I'll just use sine of 50 and the 10 again. So here we have 10 sine of 63.2 is equal to X sine of 50. To get the X by itself, we just need to divide both sides by sine of 50. In my calculator now, I'm just going to type this in. Let me get my fraction button to make life easier. 10 sine 63.2 over sine of 50. And to the nearest tenth, X is approximately 11.7. So BC is approximately 11.7. This was a long video, but this was a long review sheet. And I did try to go through everything very slow.